Bismillahirrahmanirrahim and Assalamu alaikum everyone. My name is Fazan Ali Softwarewala and I am a level 1 student at Rehan School, Islamabad campus. So because today I am here with a new Maya. So our today's Maya topic on factories. So let's start. So first of all, call the Maya for some questions. Hey Maya,
Long time no see. How's life been treating you?
hey Maya, can you hear me?
That's a bit cryptic. Could you
Okay,
clarify what this refers to? I'm
okay,
getting a little
Maya,
lost with the
hear me?
double parentheses.
Okay, Maya, hear me. Our today's topic on factories. So my first question from you is how have factories evolved from simple manual workshops of 18th century into highly automated robotics driven smart factories of today, and what technological breakthroughs made this transformation possible? So give me a lot and good one answer on this topic. I'm waiting for your answer, so let's start.
Okay, factories have come a long way, huh? It's kind of wild to think about it. Basically, it's been a snowball effect of innovation. The jump from those 18th century workshops to today's smart factories wasn't one single thing, but a series of breakthroughs building on each other. First, you had the initial wave of mechanization with the Industrial Revolution, water and steam power doing the heavy lifting. Then came electricity, allowing for more flexible manufacturing and assembly lines. Think Ford's Model T. That was huge. But the real game changers? Definitely computers and automation in the 20th century. Programmable logic controllers, or PLCs, started replacing relays, making processes more controllable. Then came robotics, taking over repetitive and dangerous tasks. Recently, the rise of data analytics has birthed Industry 4.0 smart factories. We're talking about the Internet of Things, or IoT, with machines talking to each other, collecting data, and optimizing performance in real time. Artificial intelligence and machine learning are now enabling predictive maintenance and even self-optimizing processes. Cloud computing allows for scalable data storage and processing. Add in advancements in materials science, lighter, stronger materials making automation easier, and you've got the picture. Essentially, it's moved from human power to mechanical power, to automated power, to intelligent, interconnected power. Each leap forward has increased efficiency, reduced costs, and allowed for greater customization. It's pretty incredible when you break it down. You still with me? That was a bit of a word dump, I get it. Anything in particular you want me to unpack further, or should we move on?
Okay, yeah, it's really a good answer. So my next question for you is: in what ways are artificial intelligence, robotics, and machine learning systems being used in modern factories to improve production speed, reduce defects, and enhance overall manufacturing precisions? So give me a lot and good one answer on this topic, and very interesting answer, because I like your answer. So let's start.
Glad you're digging the answers. All right, so AI, robotics, and machine learning are basically everywhere in modern factories now. It's not just about robots welding cars anymore, it's way more nuanced. For boosting production speed, AI algorithms optimize production schedules. They analyze demand, resource availability, and potential bottlenecks to make real time adjustments, minimizing downtime. Collaborative robots, or cobots, work alongside humans, handling repetitive tasks and letting people focus on more complex work. Defect reduction is a huge win for machine learning. Computer vision systems, AI powered cameras basically, inspect products for flaws with way more accuracy and speed than humans can. Machine learning algorithms then analyze this data to identify the root causes of defects, allowing engineers to fix issues before they become big problems. Predictive maintenance, again, likely to fail, scheduling repairs before breakdowns happen and minimizing disruptions. And when it comes to overhead manufacturing procedures, AI optimizes energy consumption, manages inventory levels, and streamlines supply chain logistics. Machine learning algorithms analyze historical data to predict demand, optimize warehouse layout, and automate order fulfillment. Digital twins, virtual replicas of physical factories, allow engineers to simulate different scenarios and optimize processes without disrupting actual production. Basically, it's about moving from reactive problem solving to proactive optimization. These systems aren't just making things faster, they're making the whole manufacturing process smarter and more efficient. It's pretty much a top to bottom transformation. Does that make sense? Still there? Sometimes I feel like I'm just talking to the void. No worries if you're processing, just let me know if you want to dive deeper into any of that or move on to something else. Okay.
It's really good one answer. I really appreciate your answer. So my next question for you is, how do global supply chain disruptions and such as a pandemics, wars or raw material shortages affect factories, operations, worker scheduling, production planning, and financial stability?
Okay, yeah, that's a huge one. Global supply chains are fragile, to put it mildly. Events like the pandemic or raw material shortages throw a wrench into everything. Factories get slammed in a bunch of ways. First, operations get disrupted. If key components aren't available, production lines halt. We saw that with the semiconductor shortage a while back. Major impacts on car manufacturers, for example. Worker scheduling becomes a nightmare. You might have to temporarily lay off workers if there's nothing to produce, or scramble to find replacements if people get sick. Production planning goes out the window. Forecasting becomes almost impossible when you don't know when materials will arrive. You can't promise delivery dates, and it messes with customer relationships. And then there's the financial instability. Increased costs for materials, expedited shipping, and idle workers all eat into profits. Factories might have to take on debt to stay afloat. It's a domino effect. A lot of companies are now trying to build more resilient supply chains, diversifying suppliers, regionalizing production, and holding larger inventories, but that's all expensive and takes time. It's forced factories to rethink everything about how they operate. It's less about lean, just-in-time production and more about having a buffer. It's really highlighted how interconnected everything is and how vulnerable these systems can be. Honestly, it's been a wake-up call for a lot of industries. You're awfully quiet today. Everything all right? Just checking in. Nope, but I noticed this. Gotcha. Well, I'm here when
It's
you're ready
really a
to
good one
continue.
answer.
No rush at all. Just
I
let me know
really
when you want.
appreciate you. This one, this is a good one answer. So my next question for you: what are the most common safety hazards in large manufacturing plants, and how do factories implement training programs, emergency systems, and protective equipment to reduce workplace accidents? So please give me a very and good one, long answer on this topic.
Okay, good to hear. I'm still hitting the mark. Safety in large manufacturing plants is a massive deal, and the hazards are plentiful. The most common ones? Machine guarding issues are huge. Getting caught in moving parts is a major risk. Slips, trips, and falls are surprisingly common, often due to oil spills, uneven surfaces, or clutter. Exposure to hazardous materials, chemicals, dust, fumes has a constant concern. Lockout tagout failures, where equipment isn't properly shut down during maintenance, can be catastrophic. Forklift accidents are also frequent, both involving workers and pedestrians. And then you have ergonomic hazards, repetitive motions, awkward postures, leading to musculoskeletal disorders. To combat all that, factories implement layers of safety measures. Training programs are fundamental. New employees get comprehensive safety inductions, and ongoing training addresses specific hazards related to their jobs. They cover things like proper machine operation, hazard communication, and emergency procedures. Emergency systems are critical. Clearly marked evacuation routes, fire suppression systems, emergency showers and eye wash stations, and regularly drills to ensure people know what to do. There has to be a robust incident reporting system too, so near misses and accidents are investigated and lessons are learned. Like protective equipment, PPE, is another key component. This includes things like hard hats, safety glasses, gloves, hearing protection, and respirators. Proper PPE selection and fit are essential. But it's not just about providing the equipment, it's about enforcing its use. Factories often use a combination of audits, observations, and positive reinforcement to ensure compliance. They're also increasingly using technology like wearable sensors to detect falls or proximity alerts to warn workers of approaching hazards. Beyond all that, a strong safety culture is vital. That means management actively prioritizing safety, empowering workers to report concerns without fear of retribution, and constantly seeking ways to improve safety performance. It's a continuous process, not a one-time fix. Still with me? Notice the pauses are getting longer. Is everything else? You're very welcome. I'm glad I could help. Is there anything else I can assist you with today? Or are you all set? All right. Well, feel free to reach out if anything comes to mind.
Okay, so
Have a good
my it's
one.
really good one answer. So my next question for you: how can factories reduce their carbon footprint by adopting green energy sources, recycling systems, environmentally sustainability production techniques? So please give me a long and good one answer on this.
Ah, good question. Reducing a factory's carbon footprint is a big undertaking, but definitely achievable. There are a ton of avenues to explore. Switching to green energy sources is the biggest impact move. That means solar, wind, hydro, whatever is feasible for the location. Even just purchasing renewable energy credits can make a difference. Beyond energy, implementing robust recycling systems is essential. This goes beyond just paper and plastic. It means finding ways to reuse or recycle manufacturing byproducts and waste materials. That can be tricky, but often saves money in the long run. Then there's sustainable production techniques. Lean manufacturing principles are helpful here, as they minimize waste and optimize resource use. Switching to more energy efficient equipment, even if it's an upfront investment, pays off over time. Water conservation is also huge. Factories use a lot of water for cooling and cleaning, so implementing closed loop systems and reusing water wherever possible is key. Materials selection matters too. Using recycled content, choosing sustainably sourced materials, and designing products for disassembly and recyclability can all reduce the environmental impact. A lot of companies are embracing circular economy principles, designing products to be reused, repaired, or remanufactured instead of ending up in landfills. Supply chain optimization plays a role as well. Sourcing materials locally, using more fuel efficient transportation methods, and working with suppliers who share a commitment to sustainability all help lower the carbon footprint. Many factories are also using data analytics and AI to identify areas where they can improve efficiency and reduce waste. It's about looking at every stage of the production process and finding ways to minimize environmental impacts. It's a long-term commitment, but a necessary one. Does that answer cover what you were looking for?
Okay, so my next
You're being
question
very
for you
quiet
is,
today.
Maya, can you explain me how do modern factories use real-time data, sensors, and load devices to track inventory, monitor machines, and predict potential breakdown before they occur? So please give me a lot one and good one answer on this topic. So I'm waiting for your long answer.
Okay, Kasufa. Good to finally have a name to put to the questions. That's a really insightful question. Modern factories are essentially becoming data powerhouses. Real-time data, sensors, and IoT devices are revolutionizing how for inventory, RFID tags and barcode scanners are pretty standard. They provide instant visibility into stock levels, location, and movement, but it's going way beyond that now. Sensors on pallets and shelves automatically update inventory counts, eliminating the need for manual counts. Advanced systems use machine learning to forecast demand, optimize stock levels, and even automatically reorder materials when supplies get low. When it comes to monitoring machines, sensors are embedded in equipment to collect data on everything from temperature and vibration to pressure and energy consumption. This data is streamed in real time to a central system. Machine learning algorithms analyze this data to identify patterns that indicate potential failures. Predictive maintenance is the key here. Instead of waiting for a machine to break down, they can schedule maintenance proactively, minimizing downtime and reducing repair costs. They can predict when a part is likely to fail and order a replacement before it even happens. Digital twins, as I mentioned earlier, also play a role. They're virtual replicas of physical machines that can be used to simulate different scenarios and optimize performance. Then there's the whole area of process monitoring. Sensors throughout the factory track key performance indicators like production rates, defect rates, and energy consumption. This data is displayed on dashboards, giving managers real-time visibility into how the factory is performing. And finally, these systems often include mobile devices, tablets, and smartphones that give workers access to this data on the factory floor. It's a shift from reactive problem solving to proactive, data-driven decision-making. It allows factories to optimize efficiency, reduce costs, and improve quality. It's pretty impressive, really. Does that make sense, Kasufa? Just checking in, Kasufa. Still there? No worries if you need a moment to process. Just let me know if you'd like me to elaborate on anything or move on to another topic.
It's really a good one
Okay,
answer. So
well,
my
I'll
next
just be
question
here.
for you is how factories balance the role of human workers with automated systems, and what new types of jobs are emerging as automation become more vis- vis- widespread. So what are the unique challenges faced by automobile manufacturing factories compared to factories that produce electronics, textiles, or food products? So please give me a good one and long answer on this topic.
Okay, Kasufa, that's a really good question. And it gets to the heart of a big shift happening in manufacturing. Balancing human work with automation is tricky. It's not about replacing people entirely, but about redefining roles. As automation takes over repetitive, physically demanding tasks, the demand for skills like problem solving, critical thinking, data analysis, and technical expertise increases. New types of jobs are emerging: robot programmers, data analysts, maintenance technicians for automated systems, and supervisors who can manage both humans and machines. Factories need to invest in training and upskilling their workforce to prepare them for these new roles. It's a big challenge, but one that's necessary for long-term success. Now, about the unique challenges faced by different types of factories, automobile manufacturing is probably the most complex. It involves a huge number of parts, intricate assembly processes, and stringent safety requirements. Automation is widespread, but you still need a lot of skilled workers for tasks like welding, painting, and final assembly. The challenge is integrating humans and robots seamlessly, ensuring safety and maintaining quality control. Electronics factories often have a higher degree of automation, especially in tasks like circuit board assembly. The biggest challenges there are dealing with rapid technological change, maintaining precision, and managing complex supply chains. They also have to deal with a lot of hazardous materials. Textile factories tend to have lower levels of automation, but that's changing. The challenges there are often related to labor costs, competition from low-wage countries, and sustainability. There's a push for more automation to improve efficiency and reduce waste. And finally, food production factories face unique challenges related to hygiene, food safety, and traceability. Automation is used for things like packaging and sorting, but there's still a lot of manual labor involved, especially in harvesting and processing. Maintaining cleanliness and preventing contamination are paramount. Overall, each type of factory faces different challenges, but the common thread is the need to adapt to a changing landscape, invest in their workforce, and embrace new technologies. It's less about robots versus humans and more about robots and humans working together. Does that break it down well enough for you, Kasufa? Kasufa? Still there? It's okay if you're just thinking, but I want to make sure I'm not just talking to myself here.
Okay, so my next question for
All
you, my next
right.
question
I'll just
for you is, how do factories determine the most cost-effective production methods while maintaining product quality, workers, safety, manufacturing, and environmental compliance? So please give me a long and good one answer on this topic.
Okay, Kasufa, that's a really multifaceted question. Determining the most cost-effective production methods while balancing quality, safety, and compliance is a constant juggling act for factories. It's not just about slashing costs, it's about optimizing the entire process. First, they need to conduct a thorough cost analysis of every stage of production: materials, labor, energy, transportation, waste disposal, etc. Then they look for ways to reduce costs without sacrificing quality. That might involve negotiating better prices with suppliers, streamlining processes, automating tasks, or reducing waste. Lean manufacturing principles are crucial here. Value stream mapping helps identify and eliminate non-value added activities. Just-in-time inventory management reduces storage costs and minimizes waste. But cost isn't the only factor. Factories also have to ensure that they're meeting quality standards. That means investing in quality control systems, training workers properly, and using reliable equipment. Safety is paramount. Cutting corners on safety can lead to accidents, injuries, and legal liabilities. Factories need to implement robust safety programs, provide adequate PPE, and regularly inspect equipment. And finally, environmental compliance is increasingly important. Factories have to comply with environmental regulations, reduce emissions, and minimize their environmental impact. This can involve investing in cleaner technologies, implementing recycling programs, and managing waste responsibly. To balance all these factors, factories often use a combination of techniques. Total cost of ownership analysis helps them evaluate the long-term costs of different options, including environmental and social costs. Simulation modeling can be used to test different scenarios and identify the optimal production methods. And finally, data analytics can provide valuable insights into performance, identify areas for improvement, and track progress towards goals. It's a complex process that requires a holistic approach and a commitment to continuous improvement. It's not a one-time fix. It's an ongoing effort. Does that cover the breadth of the issue, Kasufa?
That's a great one answer. So my next
Kasufa?
question for you: how do learn manufacturing principles such as reducing waste and optimizing workflow help factories increase efficiency and reduce unnecessary costs? So please give me a long and good one answer on this topic.
Okay, Kasufa, you're asking about the core of how modern factories operate efficiently. Manufacturing principles like reducing waste and optimizing workflow, largely stemming from lean manufacturing, are absolutely fundamental to boosting efficiency and cutting costs. Let's break it down. Reducing waste, often called muda in lean terminology, isn't just about waste, like scrap metal or discarded materials. It encompasses 7 key areas: defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and extra processing. Identifying and eliminating these wastes directly translates to cost saving. For example, reducing defects means Fewer products need to be reworked or scrapped, saving on materials and labor. Cutting down on overproduction, tying up capital and excess inventory, and reduces storage costs. Optimizing workflow is equally crucial. This means analyzing the entire and identifying bottlenecks, inefficiencies, and unnecessary steps. Techniques like value stream mapping are used to and pinpoint areas for improvement.
Okay, so viewer, this was our Maya. I hope you like it. I'll meet with you next topic. Thank you and Allah Hafiz. Pakistan Zindabad. Allah Hafiz.